So there are two different ways that you can write a vector. You can write it in magnitude and direction form, or you can write it in component form. So we're going to practice now converting back and forth between those two forms. But before we can do that, let's talk about what magnitude is. Magnitude is the length or the distance of a vector. So magnitude is always positive. Sometimes magnitude could also be called the speed of a vector if you're dealing with certain word problems. So the formula for magnitude, well, first of all, the notation for magnitude is double absolute value bars, but it's the square root of the first component squared plus the second component squared. It's very similar to the distance formula that you're used to from your previous math courses. So let's practice finding magnitude with a couple vectors before we convert between the two forms. So for vector u, 4, -5, we're going to take the square root of 4 squared plus -5 squared. Make sure anytime one of your components is negative that you put it in parentheses before you square it. So this is going to be the square root of 16 plus 25, which becomes the square root of 41. All right, so what you want to do is see if that number has a perfect square. If it does, go ahead and take it. 41 does not have a perfect square. If it doesn't have a perfect square, then you want to see if you can make a factor tree out of it. See if you can break it down into factors. But 41 is actually a prime number, and so you can't branch it out or anything, so you're just going to leave your answer as the square root of 41. Okay, next example, we have -3 and 6. So we're going to do the square root of -3 squared plus 6 squared. All right, so that's the square root of -3 squared is going to be 9, and 6 squared is going to be 36. And then 9 plus 36 is 45. 45 does not have a perfect square, but it can be branched out. So if you think about a factor tree for 45, you can branch 45 into 9 times 5, or you could also use 3 times 15. And you want to keep on branching until the numbers are prime. 5 is already prime, but 9 keeps branching into 3 and 3. All right, you get a pair of 3's. So when you get a pair, you bring that number to the front. So that becomes 3 square root, and you leave this 5 on the inside. So 3 square root 5 is the magnitude of that one. So you want to practice giving these magnitudes in simplest radical form, unless you're told to round to a decimal. Then you can get a decimal answer. Okay, so that's what magnitude is. So now let's practice going back and forth between component form and magnitude direction form and vice versa. All right, so when you're going from component form to magnitude and direction form, you first have to find the magnitude using what we just did right there, the formula above. Let me write that out. To find the magnitude, you're going to use the formula above. Okay, to find direction, you're going to use a little bit of trig. Since your vector has two components, an x and a y, we can use x and y and some trig function that we know to find the direction. We know that tangent is the same as y divided by x, so we can do tan theta equals y over x. And then that will turn into theta equals the inverse tan of y divided by x. Now, y divided by x is really actually going to be component 2 divided by component 1 in our vector. So we're going to do these two steps, and we can find the direction that our vector goes in. All right, so for the first example, we have vector v, 6, -6. Let's find the magnitude first. So the magnitude, use your double absolute value bars. The magnitude of vector v is going to be the square root of 6 squared plus -6 squared. All right, so that's the square root of 36 plus 36, the square root of 72. Okay, 72 is not a perfect square, but it can be branched out. So you can branch 72 out into 8 and 9, And you can keep branching the 8 into 2 and 4, and then keep branching the 4 into 2 and 2, and then you can branch the 9 into 3 and 3. So this time you have a pair of 2s and a pair of 3s. So that means out front you're going to bring a 2 and a 3, so a 6 out front. And then this 2's left over, so that's what's going to go inside. So your magnitude is 6 square root 2. Okay, now you want to find the direction. So we're going to do tan theta equals y over x, or component 2 over component 1. Okay, tan theta equals negative 6 over 6, which reduces to negative 1. So this is really just tan theta equals negative 1. So this means what angle is the tan negative 1? This is from the unit circle. When you see that this value comes from the unit circle, you should not have to use a calculator for this. You go straight from memory. Okay, so there are 2 places in the unit circle where the tan is negative 1. Tan is always negative in quadrant 2 and quadrant 4. So in quadrant 2, the tan is negative 1 at the angle 135 degrees. And in quadrant 4, the tan is negative 1 at 315 degrees. Those are your 2 45-degree angles, okay? But obviously, this vector can't go in 2 different directions, so we have to figure out which one of these is the correct answer. So to do that, go back and look at your vector. Your vector was 6, negative 6. And if you're thinking about the coordinate plane, if your first component is positive and your second component is negative, that means if you're starting at the origin, you're going in a positive direction first, you're going this way first, negative direction next, so you're going this way next. So you're landing down here in quadrant 4. So you want to take the quadrant 4 answer. So your direction is going to be 315 degrees. Okay, let's look at the second example. Vector v, negative 2, 5. Okay, go ahead and find the magnitude. So this will be the square root of negative 2 squared plus 5 squared. All right, so that's the square root of 4 plus 25, or the square root of 29. Okay, 29 does not have a perfect square. It also doesn't branch out because it's prime. So our magnitude is just going to be the square root of 29. Okay, let's find the direction. So we have tan theta equals second component divided by first component. 5 divided by negative 2. And typically when we write a fraction, when the negative is on the bottom like that, we typically just move it to the top. So this is negative 5 halves. Now, negative 5 halves is not from our unit circle. So when this happens, we are going to use our calculator for this because we don't know where the tan is negative 5 halves at. So you're going to go to your calculator and you're going to type in arctan, or tan inverse, of negative 5 halves. Make sure you're in degree mode. Okay, so you're going to hit second tan negative 5 divided by 2 and see what the calculator gives you. Okay, the calculator is giving me negative 60, I'm going to round to the nearest tenth, negative 68.2 degrees. So theta is negative 68.2 degrees. Okay, so let's see if that's what we want. First of all, if it's given me a negative angle, that means rather than opening up, I'm opening down. So the calculator is giving me this down here, negative 68.2 degrees. It's giving me a quadrant 4 answer. If I look at my original vector, my vector is negative positive. So if I'm starting at the origin, negative means I'm going left first, and then positive means I'm going up. So that means I need a quadrant 2 answer. Okay, so rather than quadrant 4, I need quadrant 2. So I want the reference angle from quadrant 4. I want to take my reference angle from quadrant 4 and use that reference angle to go up into quadrant 2 and get the angle I need in quadrant 2. Or remember that a reference angle is just how far is the angle from the closest side of the x-axis. Well, this negative 68.2 is my reference angle if I just change it to a positive angle. I'm 68.2 degrees away from the x-axis. I just need it positive. Okay, so I'm going to take that 68.2 over here into quadrant 2. Okay, how am I going to get into quadrant 2 using that 68.2? Well, this time I'm closest to this side of the x-axis. So I'm going to use 180 degrees to get into quadrant 2. I'm going to take 180 degrees and I'm going to subtract 68.2 because quadrant 2 is less than 180. So 180 minus 68.2 gives me 111.8 degrees. That puts me in quadrant 2, which is the quadrant that I need. So when you're finding these directions, you're using things that we've done in previous chapters. So you're using reference angles and you're using coterminal angles and things like that to get the angles that you need. Okay, so everything's building on things we've done before. Don't trust what the calculator gives you as your final answer. Okay, now going in the other direction. We want to convert now from magnitude and direction form to component form. If I'm given a magnitude for my vector and I'm given the direction that my vector goes in, can I get it back into this bracket form? So the formula for doing that is right here. I take the magnitude of my vector and I multiply it by the cosine of my angle and the sine of my angle. Okay, so for the first problem, my magnitude is 3, my angle is 0. So I'm going to take the 3 and put it out front, and I'm going to do cosine of 0 degrees and sine of 0 degrees. And so this is where the unit circle comes in. You want your answers to be exact if possible. All right, what is the cosine of 0 degrees from the unit circle? Remember, cosine is x in the unit circle. The cosine is 1 at 0. The sine is 0 at 0. And now you're going to distribute that 3. So my component form is 3, 0. Okay, second example. My magnitude is 3 square root 2. My angle is 150 this time, so I have cosine of 150 and sine of 150. Remember, this is all corresponding to things we've talked about before. Cosine is in the x spot, sine is in the y spot, just like with the unit circle. Okay, think about where 150 is. You're in quadrant 2. You're 30 degrees away from the x-axis. What is the cosine of 150 degrees? It's negative square root 3 over 2. It's negative because you're in quadrant 2. The x is negative in quadrant 2. The sine of 150 is positive in quadrant 2. It's 1/2. Okay, now you're going to distribute the 3 square root 2 to this. Remember that when you have a scalar out here, it only goes to the numerator of these fractions. So 3 square root 2 times square root 3, those two square roots can multiply and become square root 6. So you have negative 3 square root 6 over 2. And then you have 3 square root 2 over 2. Because that 1 right there is not going to change anything. So there's the component form of that vector. So far, both of these angles have been from the unit circle. You haven't had to use your calculator. You're given exact answers, not rounded answers. Okay, last example, magnitude is 8. This time my angle is 272. 272 is not from the unit circle. So now I'm okay to use the calculator. All right, so we're going to type in 8 times the cosine of 272. 8 times the cosine of 272. Make sure you're in degree mode, and I am. 8 9 272 gives me point. I'm just going to do 3 decimal places, 279. And then we're going to do 8 times the sine of 272. and I'm getting negative 7.995 for that one. And there's the component form of that vector.